Great, I think we can get started. Welcome to another seminar in our Esdras Roundtable Seminar Series. Today is a great pleasure for me to have Dr. Chris Atkinson. He's the Deputy Director of the Advanced Research in the Office of Assistant Secretary for Research and Technology in the U.S. Department of Transportation. He also the director of the Smart Mobility Initiative and professor in mechanical and aerospace engineering at Ohio State University. Prior to these roles, Dr. Atkinson was the program director in ARPA-E, where he initiated and managed more than $120 million projects in the area of advanced clean energy. One of the flagship initiatives of him was the creation of the NextCar program, resulted in a big ecosystem of faculty, industrial stakeholders, PhD students, master students, who all work into developing control technologies using connectivity and automation to improve the efficiency of vehicles by at least 20%. That was a big success, a very successful program. Dr. Atkinson is also the founder of Atkinson LLC, a consulting company in the area of advanced engines and vehicle technologies. He has authored more than 70 publications which have attracted considerable attention in the community. He's a fellow for SME, of SAE, and also has received, he's the recipient of the Louis Moody Award of ASME in 2012. With this, please join me in welcoming Professor Dr. Chris Atkinson.
Thanks very much, Andreas, and I'm incredibly impressed that you memorized that. That's really good. Thank you. It's untouched. As Dr. Professor Malakopoulos said, I'm Chris Atkinson. I'm a professor of mechanical engineering at Ohio State University. As he also said, I'm currently on loan to the U.S. Department of Transportation, helping the U.S. DOT set up the Advanced Research Projects Agency for Infrastructure. But today I'm addressing you as a professor of mechanical engineering from OSU. I'm going to talk to you about the challenges facing the transportation industry today, and specifically road transportation, in other words, all things automotive. Why? Because that's the vast majority of the transportation that we see and feel and experience around us. It is also the most impactful from the point of view of both energy and safety, and I'll talk more about safety in a while. Safety is the number one consideration. Electrification and automation, I understand that many of you work in those areas, but I apologize in pricking your bubble. They are not the most important things in transportation. Safety is the most important things in transportation. Right, so transportation is facing several transformations simultaneously. Decarbonization. Why decarbonization? Two reasons. One of which is that the United States and many other countries in the world have agreed to decarbonize their entire economies by 2050 in the case of the United States. And secondly, that transportation is now the largest emitter of greenhouse gas emissions in the United States. It overtook power generation about 6 or 7 years ago. Why? Because coal use in power generation has plummeted in the United States. Natural gas use has increased significantly. Renewable energy generation has increased significantly. But also transportation vehicle miles traveled, VMT as it's called, rise at about 3% year over year. And so rising demand, the increasing decarbonization of power generation, those two have conspired to make transportation the single largest emitter of greenhouse gases in the United States. Automation, you know all about automation, vehicle automation is critically important. The thing that I think most about automation is that, and I mentioned it earlier this morning, is that decades from today, 30, 40 years, you pick the decade, all vehicles will be automated. There'll be no human intervention. They'll drive perfectly well, crisscrossing the countries of our country and the world in an entirely safe, comprehensive and efficient fashion. However, today we have a human-driven fleet. And the confluence of those two, the human-driven fleet will be around for the next 30 years. If we decided today that in 30 years all vehicles will be automated, it would take 30 years for the human driver essentially to move out of operation. And the interaction between human drivers and automated vehicles is the most difficult problem that we have to solve. The easy solution is the one that will emerge 50 years hence. And we as humans are not used to solving the most difficult problem first. We solve the simplest of problems first and build upon those and ultimately solve much more complex problems. But we and us and you are being called upon to solve the most difficult problem first, which is the mixed human-automated vehicle interaction. And then, of course, connectivity, and I mean that in terms of vehicle-to-vehicle connectivity, but also vehicle-to-infrastructure, infrastructure-to-vehicle, and perhaps you can even think of vehicle-to-grid types of connectivity. And again, safety. Safety is our number one consideration. In the United States, each year, roughly 43,000 people are killed in roadway crashes, fatalities. It's a tragedy, number one, but it's a scandal, number two. And it behooves us as academics and as practitioners in the field to do something about that. And I'll talk more about that. Bear in mind, when I say 43,000, I'm not being glib. Behind each and every one of those statistics is a real person, a mother, a father, a brother, a child, a sister. And we must not lose sight of that. As transportation professionals, which is many of you are evolving to be, we cannot lose sight of that fact, and we should not lose sight of that. Give you a bit of a background. Andreas told you about me. I've been an academic 3 times over. I've been an entrepreneur. Not a tremendously successful one, but I lived by my own wits for 15 years, so that's good enough, I guess. I've been a federal government employee, and now I'm the proud owner of 2 EVs. Right? So I believe in electrification. I also believe in automation, although I like to drive myself. You're also in the presence of an influencer. Look, see, 105,000 views of my post, and I got a nice shout out from Jim Farley, the CEO of Ford. Right? I went back and looked. I bought 17 new vehicles over 31 years, 11 gasoline, 1 diesel, 1 flexible fuel vehicle, 1 hybrid, 1 plug-in hybrid, and 2 EVs. So you can see my transition has been much the same as the automotive industry's transition. Why are we worried about decarbonization? We're worried because, as I said, transportation has now exceeded electrical energy generation in terms of greenhouse gas emission. What you're seeing here is, on the left-hand side, energy sources, and on the right-hand side, energy sinks of the United States. This is the United States alone. It's in the units of quadrillion BTUs annually. In this case, it's a horrible unit, but ignore that, because 97 are consumed. It's roughly every number you see on this chart is a percentage point, right? On the left-hand side, you can see petroleum, which is largely used for transportation as well as for petrochemicals, biomass. That a lot of that goes into transportation. Why? It's in the form of ethanol and biodiesel. As you know, gasoline is between 10 and 15% ethanol. Coal use is declining, natural gas is increasing, and then these are the zero emissions. So this is an energy flow. It's not greenhouse gases, but of course, if you knew the conversion between each of these, you'd be able to determine that. This, by the way, is the Sankey diagram. Who of those have seen a Sankey diagram? Okay, the rest of you should know what the Sankey diagram is, absolutely, because we're living in the area of decarbonization, and this tells you the story. These are decarbonized energy sources: solar, nuclear, hydro, wind, geothermal. These are carbon intensive, with coal and petroleum being the most carbon intensive energy forms. This is where energy is used on the right-hand side: transportation, industry, commercial, residential. These are energy services that are useful. This is rejected energy. And you can see the comparison. 2/3 roughly of all energy is rejected. Why? Because we have coal and natural gas-fired power plants that put out an enormous amount of heat to the atmosphere. And then we have internal combustion engines in transportation that put out enormous amounts of energy to the environment. So in terms of decarbonization of transportation, I'll draw your attention to this little thing here, the 0.02, which is the electrical energy generation that's used in transportation. What we have to do is we have to take this number and make it match that number. We have to increase that number to that point there, right? Not only that, but we can't have any of that power coming from natural gas or coal. It has to come from these 5 here, right? Decarbonized power. Geothermal is small and emerging. Nuclear, we're not going to permit another nuclear plant. It takes 25 years to do so. Hydro, we're not going to build another large dam in the United States for environmental reasons. So it has to come from wind and solar. So wind and solar need to increase in order to match this number at a bare minimum. That's the decarbonization challenge that faces transportation and the decarbonization challenge that faces our country. So it's the energy generation on this side, and then it's the transmission and distribution. We need to get that power from where it's generated to where it's used. So we need significant build out of our electrical grid. We also need to recharge vehicles, so we need significant build out of recharging capability. Are you beginning to see the scale and the scope of this transformation that's hitting us? Then I glibly said wind and solar, right? Wind and solar are intermittent, whereas our use of power here is not intermittent. We drive all hours of the day and night. So we're going to need grid level storage. So we need increase in renewable energy generation, increase in grid level storage, increase in transmission and distribution, increasing in recharging. And then of course we need to produce the vehicles themselves and the batteries that power them. And then we need to make sure that people implement these. So we need to provide incentives for people to purchase. And I'll talk more about that in a while. But our road transportation reality in the United States, we drive, light duty is LD, medium, MD, HD is 5 duty, heavy duty, I beg your pardon. We collectively drive in the United States 101,000 miles per second, right? 101,000 miles per second, 24 hours a day, 365 days a year. Fuel consumption, a large gasoline tanker that you see refueling a gas station, one of those every 1.5 seconds of every day of the year, of every hour of every day. Number of vehicles in the United States, 270 million of them. They average about 12 years old for light duty. We used to sell about 17 million new light duty vehicles a year. It's dropped significantly in the pandemic. It's climbing back up to there. Heavy duty sales are half a million or so. Average new light duty vehicle price in 2023 is $48,000. EV sales are 7.9%. I said of the order of 9%, it's not 7.9% so far this year. The average EV price is substantially higher than the average new light duty vehicle price, by $17,000 or so. 39% of US counties, 39% have 0 public chargers for EVs, which means that people charge them themselves in their own garages or in private charging. But this is a significant impediment to the rollout of vehicles. So, by 2050, the vast majority of the light duty automotive fleet, and by light duty we mean passenger cars, SUVs, light trucks, minivans, the sorts of things that you and I drive around in, and the vast majority of those are privately owned. They'll be electrified if we've resolved the issues of critical materials and minerals. I'll talk more about that in a while. If the grid is essentially decarbonized through renewables, if vehicle purchase costs have been reduced, and if EV charging opportunities are ubiquitous, meaning you can charge at home, but if you go beyond the normal vehicle range on your EV, you need to be able to find recharging capabilities. This is just another graphic which says exactly the same thing, but it stresses the fact that we need to resolve these things simultaneously. Significant build-out of renewable energy, significant build-out of the grid. And by the grid, we mean the first 1,000 miles, so the very large, high-voltage towers that you see with lines strung between them, the first 1,000 miles essentially, and the last 100 feet, meaning if you live in a house or a dorm or a building such as this, they might need to add electrical power capability in order to improve the capability to charge EVs. critical materials and components. And those are battery materials, things like lithium, cobalt, graphite, manganese, nickel, a number of others. Rare earths, which are used for electric machines, specifically things like permanent magnets and so on and so forth. And then still semiconductors. And those are both for microprocessors, but it's also for switching for power, both at the millivolt level for your laptop, but also at the thousands of volt level for the grid. And then there's EV and battery manufacturing, and then there's vehicle affordability and consumer pull. The consumer needs to demand these vehicles and want to have them and want to use them preferentially. So we're actually doing a pretty good job on EV and battery manufacturing. You know, we need 50 battery plants in the United States to meet our 17 million vehicles a year, at where each plant is about 30 to 35 gigawatt hours per year of battery production. We're doing a fairly good job of that. We have 15 either under construction or planned, 15 of 50. We're doing an absolutely terrible job of that. We're doing a not very good job of that. We haven't really started that. We haven't really started that. And then this, vehicle affordability, is a significant problem too. And this pretty much says in words what I've just shown, but we need, for transportation and electrification, we need a 3x, 3 times increase in the current solar and wind capability. And that's before we decarbonize industry and before we decarbonize residential heating and cooling, for example. So you've heard a lot about the proliferation of heat pumps for heating and cooling. A remarkable technology, very efficient, coefficient of performance of 3.5, which means for every 1 unit of electrical energy you put in, you get the benefits of 3.5 units of heating or cooling. A remarkable technology. But before we can do that and electrify, take away someone's natural gas fired furnace, for example, we will need to increase renewable energy generation. And a near doubling of the existing high voltage grid, again, just and 100 times increase in EV charging, 100x increase in EV charging for light duty, medium duty, and heavy duty. We need a complete transformation of the automotive industry, and this is underway. A complete revamp of critical materials supply. That's problematic. We can source lithium in the United States. There's lithium in geothermal brines. There's a big lithium deposit we found on the border of Nevada and Utah. But none of that beneficiation, taking the raw ore and producing lithium carbonate or lithium hydroxide for batteries, for lithium batteries, none of that takes place in the United States. And it would be very difficult to permit in the United States. Why? Because they are, by their very definition, dirty processes. As well as we need significant increases in customer and consumer demand. This is something that we can't understress. We're talking about mechanisms and systems and technologies and processes and procedures and materials, but there's humans involved, right? And we need to keep thinking of that, human factors and human behavior. Each of these 5 revolutions is underway, proceeding at different rates, different levels of finance required. Basically, the bottom line is we're at the beginning of a decades-long transition with respect to the electrification of the automotive fleet and the electrification of transportation. And it's highly uncertain in nature, and it's going to cost us trillions of dollars, trillions, meaning thousands of billions of dollars in the aggregate. To electrify all vehicle miles traveled in the United States would add about 43% to US annual electrical energy demand, right? It's doable, but again, this is a graphic representation of the challenge. It cannot come from petroleum, it cannot come from natural gas, it cannot come from coal, it cannot come from nuclear, and it cannot come from hydro. It has to come from that. So that area has to expand to 100% of available energy requirements in the United States. You're beginning to see the challenge of this transformation. That's just on the energy production or generation side of things. In 2018, 2019, a complete irony is we achieved energy independence in the United States. We've been fighting for it for 70 years or so. We achieved it. And virtually at the time that we achieved it, we decided to jump architectures of vehicles away from fossil fuel driven vehicles to electric vehicles. Now the beauty of using electrical energy as your energy source is that by definition, because we are a continent essentially, the United States, we'd be largely free from imports. Although bear in mind, we do import natural gas and petroleum from both Canada and Mexico. There's flows back and forth across the boundaries. But if you're going to use electrical energy, that sort of by definition means that you're producing your own power along the way. But again, there's this notion of trading energy independence for complete dependence on others for critical materials, the critical materials that are required to undertake this transition. New vehicle economics. We used to sell about 17 million vehicles a year. This dates back to 2014 or so. Then we had the pandemic, a significant drop to a little over 8 million on an annualized basis by quarter. And we're now up to 13 or 14 million, right? We haven't recovered to 17 million. Why? Affordability is an issue. And then there's the availability, as you know, of semiconductors. And semiconductors, not simply microprocessors, a $200 microprocessor that runs this laptop, but it's also 50-cent semiconductor switches for all sorts of things. Everything from your seat to your seat heater to your dashboard to the switching the windshield wipers on and off and so on and so forth. This is one of the issues, is that affordability is a real problem. The real median household income in the United States is $70,000 a year. We tend to lose sight of that because we are typically, by and large, we are wealthy sorts of people. And it's been many decades since the average US household has been able to afford the average new car. They don't. They buy second-hand cars, right? And that is a further issue, is that if we are that far down in annual vehicle sales, you can't simply say it's $576 billion with a B lost in sales in 4 years, and so the OEMs, the automakers, have lost out. No. There are far greater societal issues. One of which is that the vehicle fleet ages because people tend to keep hold of their used cars longer. And it means that the cascade that we normally see, where wealthy people buy new vehicles, trade in a vehicle, or sell it to someone who's below them essentially in the economic household income chain, they then have the benefit of a fairly new vehicle, and then so on and so forth. If you break that chain or if you disrupt it, the vehicle becomes older, it becomes less safe. The vehicles become less safe because they are older. The vehicles become higher emitting in terms of criteria pollutant emissions of hydrocarbons, CO, NOx, particulate matter. And the vehicle fleet becomes less efficient. Why? Because the new vehicles are much more efficient on a fuel efficiency or energy basis than old vehicles. And so again, you disrupt that chain, you disrupt that cascade. The vehicle fleet becomes older, less safe, higher emitting, and less fuel efficient. If you shut off the flow of new vehicles to the upper end of the market. I hope that's understandable to you. And again, safety is critical. Safety is an issue that we typically overlook. So in other words, the vehicle fleet, if you differentiate it into a bimodal of horrible old vehicles and beautiful new vehicles that are very expensive, on average, the vehicle fleet becomes less safe, higher emitting, and less fuel efficient. And that none of those things are good. Now, in terms of the critical materials, this is from the International Energy Agency, and this is a sustainable development scenario of 2040 compared to 2020. This is actually outdated. It's 2021. It's 2 years old. It's already outdated, but it doesn't matter. For the purposes of what I'm about to say, it describes it. And it says, for example, for lithium, we need to increase both lithium mining and lithium production by a factor of 42. 42. Graphite, why? Because graphite is used extensively in batteries by a factor of 25, cobalt by 21, nickel by 19, rare earths by a factor of 7. These are multiples of 7. We need to scale up our mining industry today, our extraction industries today, and the beneficiation or processing of those raw materials by these factors for these critical materials. And why are these the ones that are chosen? Because these are the ones that are required for electrification. Lithium, graphite, cobalt, and nickel in batteries, rare earths in electrical machines, generators and motors and actuators and so on. These are the levels at which we need to increase this, right? And the idea is this is 2040 relative to 2020, within 20 years. So these are staggering amounts. Bear in mind further that mining we collectively, as a very developed nation, we've avoided mining. We've given that job to other people to do. We haven't wanted to do it. It's a dirty business. Literally, it's a dirty business. And we've stepped away from it. Now we have to re-embrace it, right? So things are going to change. Things are going to change radically. Battery pack costs, the idea was that battery pack costs would just decrease significantly over time. And this is dollars per kilowatt hour at the pack level, 2022. And unfortunately, you can see what people predicted, which is that they would go to $50 per kilowatt hour at the pack level. No, there's been a reversal. Costs have actually increased in recent years. And why? And that's a lot of that has to do with the costs of the underlying fundamental raw materials. So the lithium, the cobalt, the nickel, the manganese, and so on. Right. So 100 kilowatt hour, which is a large battery pack for a light GT vehicle, but that's $15,000. And that's just the raw cost of it. In a $65,000 vehicle, that's 25% of the cost merely goes into the battery alone. Significant issues. Refueling or recharging rates, you might have seen this before, but a light duty car, when you fill it up at the gasoline pump, 10 gallons a minute, it gives you 300 miles per minute of recharging capability, right? Level 2 charging at your home is 0.35 miles per minute. So it's a factor of 1,000 difference. A heavy duty truck, when it pulls up to a truck stop and they put in the big filler, it's 180 miles per minute. An EV truck charging at 1 megawatt would be 5.5 miles per minute, right? As you know, heavy duty trucks, when they're not moving, they don't earn money. And that's what heavy duty trucks are supposed to do for our economy. It's provide things we need, but also make money for the people operating them. And so that's a tremendous worry. And that's a 1 megawatt charger, right? So how many of you have owned or drive or have operated an EV? I know that Ricardo does. Okay, but you're talking about a cable thicker than your arm for this 1 megawatt recharger on a heavy duty truck. And you've all driven on the interstate and seen a truck stop where there's been 50 or 100 or 200 or 300 trucks. Just think of those, or a truck stop, a rest area. Think of 300 trucks a night having to charge at a megawatt apiece. This is the scale and scope of the transformation. Government interventions. I spoke of the sort of technology push, if you like, but there's a consumer pull. And we're doing a pretty good job of that. There's tax rebates for light duty vehicles, there's incentive to manufacturers, there's a much higher awareness of the critical materials and minerals supply chain problems in the US. There's a lot of reshoring of manufacturing and the reindustrialization of the United States. We need to move higher up the critical materials chain. As I said, we need to mine our own lithium and upgrade it and beneficiate it within the United States. From a critical economic security point of view, we're funding the electric charging build-out. There's the US Department of Energy, US Department of Transportation Joint Office on Energy and Transportation. And they're doing things like, what is the optimum siting of recharging systems within a certain geographic area? We need standards. Why? Because industry loves standards, and that's in charging, that's in V2X communications, for example. And what about automation? I haven't spoken much about automation, except to say it's happening at pace, and it's a very, very difficult area, especially in the notion of a mixed vehicle fleet of humans and automated vehicles combined. Now, greenhouse gas emissions in a material constraint scenario. We are material constrained. Why? Because we can't scale up lithium production by a factor of 42, not easily. So it just turns out that if you think of an internal combustion engine vehicle, a hybrid electric vehicle, by which you mean a strong hybrid, much like the original Prius, for example, a plug-in hybrid which carries a battery pack as well, where the hybrid does not carry a battery pack, and then a full EV. The fleet average CO2 emissions in terms of gram per mile, based on the current United States power plant emissions as they exist today, the lowest greenhouse gas emissions, CO2 emissions, are not the EV, and they're certainly not the internal combustion engine vehicle, but they are a hybrid. and it's a regular hybrid. It's not a plug-in hybrid. So if we're truly worried about what if we had an incremental 1 ton, for example, of lithium, and you say to yourself, where should we spend that 1 ton in order to reduce our CO2 emissions? It's not in EVs, it's in hybrid electric vehicles. Now, at the point at which we're no longer materials constrained, and we have decarbonized the grid, and we have grid build out of the transmission and distribution, then of course we want to build these. But there is a transition that we've ignored. There is a transition that we should have undertaken that we've essentially ignored. Again, I said to you early on, electrification, automation, and something else, connectivity. Can't remember what I said. I said those aren't the most important. The most important is safety. Right? 43,000, roughly 43,000 fatalities a year in the United States. That's both a scandal and a tragedy, and something that we collectively should do something about. You can see the number of fatalities. These are in recent years, and on the right-hand side, it's fatalities per million miles traveled. No, per 100 million miles traveled. I beg your pardon. 100 million miles traveled. And it's roughly 1.4 fatalities per 100 million miles traveled. Now, admittedly, why is that? Because these are human drivers, by and large, and humans are both incredibly good drivers. I mean, look at Formula One drivers, for example, and they're incredibly bad drivers. I was telling everyone, I walked from the Statler Hotel down to Hollister Hall this morning, and someone drove through a red light, right? Happens all the time. You have to have your wits about you as a pedestrian. But these are things that are readily avoidable and shouldn't happen. These things simply should not happen. So it's human behavior and human factors that we have to take into account. And again, with respect to vehicle automation, we're going to have a mixed vehicle fleet. We're going to have human drivers, we're going to have pedestrians on the roads, we're going to have cyclists on the roads, and we're going to have automated vehicles. And all of these issues have to be solved and resolved. But again, I wanted to draw your attention to the fact that these numbers are scandalous, and they're going to persist because we're going to have human drivers for the next 30 years. And this is something that we collectively should do something about. I just picked up some pictures here. This is the cruise vehicle that rear-ended a bus in San Francisco recently, and this is another cruise vehicle that a truck was making a sharp left-hand turn and it simply drove into the side of it. So I'm not saying that humans don't do these. Humans do these sorts of things all day, every day. But it's just emblematic to you that automation is currently not a well-resolved issue and will remain difficult and intractable for some period of time to come. It doesn't mean that people should stop working on it. To the contrary, you should double down your efforts. But you should bear in mind that it is a significant and serious issue. It's something that needs to be resolved. Professor Malakopoulos spoke of the RPE Next Car program, and I had to include this slide out of pride because the idea there was to use low levels of automation. So there are levels of automation where the driver still needs to keep his or her hands on the wheel at all time, but it can control the vehicle speed, it can control the vehicle braking, and to a certain extent it can control lane keeping. And the idea is that, well, this is demerging, Andreas. I guess it's not merging. I was going to say it's merging, but it's demerging. The idea, here's a vehicle, a ghost vehicle that's changing lanes, for example. The idea is that, as Andreas said, you can have significant energy efficiency improvements to a single individual vehicle if you allow the machine to take over the low levels of automation and you get it to drive in a more sensible fashion than a human driver. And by significant, I'm meaning 20 or 30% improvements, which, as you know, are fairly remarkable. Right. Separately, the US Department of Transportation, and I've mentioned to you that roadway safety is a critical issue. 27% of all fatalities in the United States, all roadway fatalities, occur at an intersection, a roadway intersection, right? And that's both signalized, meaning it has traffic lights and traffic signals, and non-signalized intersections, both 27%. So of the 43,000 fatalities I spoke of earlier in 2021, roughly 10,000 of those occurred at intersections. And it's a combination of drivers and vehicles, passengers and vehicles, but also pedestrians and cyclists, people pushing strollers, people in wheelchairs, and so on. And so it occurred to the US Department of Transportation to say, look, if we have automated vehicles today that are driving the streets of San Francisco and Chandler, Arizona, and they use machine vision and perception with a multiple of modalities. They use sensor fusion, they use real-time onboard path planning to decide where to drive next, and real-time decision making. If we believe collectively as a society that those technologies are good enough for us to allow these vehicles to drive on our streets, and apparently we do believe that, then surely we can take those same technologies out of the vehicle and put them in an intersection and look down on an intersection, determine where the cars are traveling in real time, determine where the pedestrians are traveling in real time. I want to get a picture. There we go. Determine where the vehicles are moving in real time, determine where the pedestrians are walking in real time, and then alert them, respectively, if a collision or an incident is about to occur. And that's the idea behind the US DOT intersection safety system, is to use emerging low-cost machine vision sensors, sensor fusion, real-time data analytics to improve situational awareness and to anticipate safety threats. The idea, therefore, is to go one step beyond that and to alert people in real time that a potential incident may occur. And again, why am I bringing this to your attention? Because it combines the notions of automation. To a certain extent, it introduces the notion of efficiency. Why? Because intersections with traffic stopping and starting are a major source of inefficiency in our driving system. But most importantly, it introduces the notion of safety. And it's something that we can do today. That's the important part. This is not something that will take decades to emerge. This is something that we can start working on immediately today, and hopefully within 5 to 10 years, come up with one or more commercial system that can be implemented in intersections to drop that number significantly, the 10,000 fatalities, drop it significantly. Why? Because again, it's an imperative that we do something. We can't simply say in 50 years we'll have a fully automated traffic system, pedestrians will be removed from roads, human drivers will be removed, everything will be safe and wonderful. No, we need to do something today. And this is an attempt to do that. It's a technology-based approach. There's a prize competition. The stage 1A closed recently, but there'll be provision for people to join the second stage, which will probably kick off next year. And the second stage is developing, training, and improving algorithms for the detection, localization, and classification of vulnerable road users. A vulnerable road user is a pedestrian, a cyclist, a person in a wheelchair, a person on an e-scooter, skateboard, people pushing a stroller, so on and so forth, using DOT-supplied sensor data collected at a controlled intersection. And it's currently a $6 million prize-based challenge. And I mention it to you because Professor Melakopoulos spoke of the RPE Next car, which I worked on a number of years ago. And this sort of is a progression of that, but distinctly with a safety flavor. The concept is something like this. There's machine vision, there's onboard computation with trajectory or prediction or estimation, there's sensor fusion, data analysis, logic and real-time decision making, and then there's warning systems. And the other methods is really code for artificial intelligence and machine learning capability. One thing I need to draw your attention to is we can't rely on the fact that all people carry a smartphone at all times, or that all vehicles will be connected. So it needs to be effective for people who are not carrying devices and for vehicles that are not connected. It has to be sort of essentially backwardly compatible, if you like. There we are. So, a summary. Electrification for light duty is well underway, but significant issues remain with regard to costs and affordability, critical materials, charging infrastructure, grid decarbonization, policies and regulations. We've traded energy independence, which we achieved for a fleeting moment, for a complete dependence on imported critical materials. Vehicle automation is proceeding, but a very, very difficult technical issue. Those of you working on it, I think, understand that deeply. And then again, our greatest problem today is with road safety. And so I want to leave you with the message of don't lose sight of the big picture. The big picture is that we're talking about transportation, automation, connectivity, and it does things like decarbonization and automation, as I say. But you can't lose sight of the bigger picture, which is that safety is our number one consideration when it comes to road transportation. People also say, well, why is, and our Secretary of Transportation, Secretary Pete Buttigieg, likes to say when he gives a talk at a conference, he says it's scandalous that you were safer flying here to this conference than you were walking across the street to the conference center. And it's true. And you have to say, well, why does that occur? It occurs for a number of reasons, one of which is that the transportation system is remarkably well controlled. We have an air traffic control system that maintains 90-second separation between aircraft. The aircraft themselves are very well maintained, but the pilots are impeccably trained, and in the cockpit, there are no distractions whatsoever. And that combination is what makes the system work in the end. But we acknowledge when it comes to roadway transportation, it's very, very messy because we're dealing with people. We're dealing with human factors and human behavior. And so you must not lose sight of that fact. It's humans, it's the humans in the mix that are the most difficult things to deal with. Yeah. Well, thank you very much. I'd like to welcome your questions.
Thank you, Chris, for the great presentation. Any questions for Dr. Atkinson? I do have a question just
Yes.
to warm up the.
Sure.
So you mentioned on the challenge, the intersection challenge, that there is, a vision of several technologies that can be used
Yes.
in an integrated manner so that we can improve safety. Is this call open for any ideas, or there is specifically you need to see a component of learning, for example, or specific components in place? Is this the goal is open to any other ideas?
It's open to any idea. We just anticipate, we came up with a concept that we believed that people would use. None of that is a requirement, but we believe that it requires machine vision for a start. It's very tough for us to think of a system that would not rely on machine vision. Now, people can say it can rely on connectivity, and the answer is no, it can't, because it needs to take into account people in vehicles that have no connectivity. So it requires machine vision. If it has machine vision, we believe it probably requires more than one modality. Why? Because you can't get all the information that you need simply from radar, LiDAR, or camera. So therefore, it's going to require some sort of sensor fusion. It's going to require path planning and prediction of both vehicles and the vulnerable road users. We believe, if someone comes up with a system that's entirely logic-free, that'll be very interesting, but we don't think so. And then there's going to need to be real-time decision-making, and then you're going to need to alert both the vehicles and the people in real time. But we're allowing for, and the warnings, are they visual, are they audio? Well, we have to take into account that there are blind people or nearsighted people and deaf people at intersections. So is it haptic? Does the sidewalk vibrate? We're leaving it open, completely open to people. So we are not specifying technologies, we're specifying outcomes for that.
That's great.
Yeah.
And another question related to that, is there any cost constraint associated with, because I remember in the next car we have some sort of cost constraints.
Yes.
About,
Yes.
there might be an idea to come up with a solution that costs millions of dollars.
Yes,
Might be
a
not
really good
sustainable.
question. And then the criteria say that we are seeking lower cost systems. Now, we are not trading off safety for
Sure.
cost, but one of the reasons why we believe that this is perhaps possible, we don't know that it's possible, but perhaps there's a glimmer of hope that it might be possible to develop a system, is that in automated vehicles, the costs of the sensor suites and the onboard computation have come down by orders of magnitude over the last 10 years or so. And so, again, the idea is to borrow from those technologies significantly, take them out of the mobile vehicle and put them in the fixed domain at an intersection, which we believe is actually an easier problem. Why? Because it is a fixed domain. Your baseline is not moving underneath you. And take advantage of the cost reduction of those technologies, the sensors, the computation, the connectivity, and so on. Yeah, so no absolute cost constraint, except that we wish to see costs low enough such that you could, in theory, deploy this at tens of thousands of intersections.
That's the idea.
And the idea would be to deploy it at the highest risk intersections first and roll it out from there. Yeah.
Questions?
Questions?
Yes.
Yes.
So your point about the number one problem being road safety, I think that was interesting to me because I am sort of someone who had forgotten about that and is mostly thinking about the decarbonization side. But I was curious if you had any numbers on how the two different problems sort of compare in magnitude of like what are the number of traffic fatalities that can be avoided versus if full decarbonization is achieved and the number of fatalities sort of worldwide with migration and natural disasters and things like that, how do those compare?
No. Another really good question, a very good question, and a question that's very high up in our collective minds. The sort of the dirty secret, that's not much of a secret, is that climate change is going to affect the most vulnerable in our world first and to the greatest extent. And the rest of us, the people you see in this room and the vast majority of the people in the United States, while things might be inconvenient for us, our lives are not going to be in mortal danger. That's issue number one. The second is that we shouldn't really be trading off one set of conditions for another. I'm not saying that you stop work on your decarbonization. I'm saying that you bear in mind that there are significant and larger issues at play. To give you an indication, over 40,000 fatalities a year for the last 25 years. That's 1 million people, 1 million people in the United States who've died on our roadways within the last 25 years. That is, if that's not an existential crisis, I don't know what is. So there's this notion of safety today versus safety tomorrow. I don't think we should be making that trade-off. I don't think we should be viewing it in that way. There's no reason to assume that we can't tackle both problems simultaneously. And I think we should. It behooves us as a society to do that. And again, we don't wish to trade off a life here for a life there. We want to improve the safety and all outcomes simultaneously. Yeah, a very, very pressing philosophical question.
Really?
Yeah.
Yes.
So I remember on one slide, and you show the comparison of the greenhouse gas emission across internal combustion all the way to the EV. It seemed like the battery vehicle, the greenhouse gas emission does not seem to reduce a lot in comparison to the internal combustion vehicle.
Yes.
Right. Yeah, here.
Two issues. One of which is that just for the purposes of this, I used the miles per gallon equivalent that the EPA designates today. Okay, so this is the RAV4, the all-wheel drive, the RAV4 hybrid, the RAV4 plug-in prime, and the Toyota BZ4X. Why did I choose those? Because they're essentially the same vehicle with 4 different driveline systems. And then these are the miles per gallon gasoline equivalent that the EPA ascribes to each of these. So it's not my numbers. This is the EPA, right? Bear in mind, this 119 miles per gallon gasoline equivalent is today's power plant infrastructure. As the power generation is decarbonized, so this number will go up significantly, right?
Yeah, so with this graph at the bottom right, it's hard for us to justify, promoting electrification so hard.
It is. That's exactly the message. And the reason is that this number needs to rise significantly. Now, a second issue that bears in mind is that this is not the total life cycle greenhouse gas emissions. This is simply the fleet average greenhouse CO2 emissions on a gram per mile basis. When you add in the life cycle costs of producing an electric battery for an EV, this looks far worse, far, far worse. So in other words, this looks much, much better. Again, it's a function of the fact that our grid currently is not significantly decarbonized. So if I'm producing an EV today, I'm using grid power from today. I'm not using grid power in 10 years' time or 20 years' time. I'm using grid power today. And that's reflected in these numbers. So you've raised a very, very good issue. Is if we wish to decarbonize, there's two ways in which we can do it. We can decarbonize overnight, and I mean decarbonize the whole, all of industry and our whole of our economy. Or we can decarbonize in a very, very progressive fashion. Just take those as two extremes. So let's say we have a wind turbine today and it's blowing on the plains of North Texas. And we use that power to dig copper out of a mine in Arizona, to upgrade the copper, to smelt the copper, to produce a new electric motor or power cables. It doesn't matter, right? There's two ways in which we can produce and I need 1 extra ton of copper today to undertake some sort of decarbonization program. I can do it using the wind power, in which case I use wind power to produce copper. It takes a long time. The carbon emissions are low, but it'll take me a long time to produce that next incremental marginal ton of copper, which means I can't use it today. I can only use it in a fairly long time. Or I can demand that the grid produce 1 extra unit of energy today using the grid as it exists today to produce that amount of copper and then implement that. You see the two extremes?
Yes.
And one is bootstrapping. And so we'll have decarbonization very, very slowly because we require renewable energy to produce the next set of materials to produce the next incremental quantity of renewable energy. Or we use dirty power today to produce a unit of electrical, of materials. And those two have completely different CO2 profiles. The one is a gentle, low profile, but it takes very long and will emit a large amount of CO2 in the interim. Or we can increase our CO2 radically in the short term in order to reduce more steeply in the long term. Do you follow my two arguments?
Yes.
And of course, we're engineers. And so we understand completely that the optimum lies somewhere in the middle between those two. But no one else understands that.
Yeah, I think the way you describe requires a superconductor, directing an orchestra, and with consisting all the good musicians, following your
Yes.
pattern exactly.
Yes.
And then you look at what is happening now in Washington D.C. Can we do that?
Well, of course the answer is no. We would like to do that. I mean, there are people who understand these things, but there's many other conditions that come into play. And the conditions that come into play, typically people say we need to decarbonize as quickly as possible. If you decarbonize as quickly as is possible, you'll increase our CO2 emissions in the short term. You'll decrease them in the long term, but you'll increase them in the short term. And as you know, being an engineer, it's the integrated area under the curve that matters, right? But we don't know the trajectory of that curve because we don't know how long these things are going to take. So there's many, many uncertainties. Decision-making under uncertainty. We're not very good at that. But certainly, we should model these systems. They're vast and enormous. We should model them. We should come up with best scenarios. Agreed?
Yeah, sorry, my last point. That sounds very scary to all of us because you see that last year in the IRA, and also in previous, the Infrastructure Act, that has almost $2 trillion.
Yes.
And many people are saying that this is an infrastructure investment many people have never seen in whole life.
Yes.
Right? And then, however, given this kind of uncertainty and also even this graph here,
Yes.
IRA has so much money to be invested in charging infrastructure
Yes.
while we are still in the dirty power. How are
Yes.
we going to wisely spend that IRA money?
A very good question. Very good question. Now, there are people who say, ultimately, it doesn't matter because you install the capability today, this number will increase significantly over time. the grid will become increasingly decarbonized, and you will have the infrastructure in place. It gets rid of the chicken and egg problem, which is where people say, I don't want to buy an EV because the recharging infrastructure is not sophisticated. And then people say, well, the recharging infrastructure is not sophisticated because not enough people buy EVs. So you're stuck in this constant loop. And the IRA is, to a certain extent, is an effort to break out of that, to remove that chicken and egg problem. To say, we have the infrastructure, now you people go ahead and buy your EVs. And you'll have certainty that you'll be able to recharge them when you want them, to the extent that you want them, at a reasonable cost, and so on. So yeah, no, really good question. The answer I want to leave you with is there's two extremes, and as we well know, because we're engineers and scientists, the optimum always lies somewhere in the middle. But we don't investigate that optimum. We just assume it's one or the other. Sure.
So since you have been in industry, in academia, in the government, and since we have many students in systems engineering here in person or online, any advice based on your experience to all these students?
Well, you mentioned system. I didn't use the word system, and I apologize. But obviously, from what I've been saying, this is a highly complex system. Right? As we were just discussing, it's a highly complex system. I mentioned the generation, the transmission, distribution, the end usage, you name it. It's a system with many moving parts is the wrong word. In many cases, they're static parts, but the interactions are not well known and not well understood. And I want to draw your attention to the fact in the end, as we've just discussed, a lot of it is human behavior and human factors that are quite difficult to take into account and quite difficult to model and manage and control. My message to you is you're working on the right thing, the right broad area, systems. Everything is systems, and everything is control. Andreas and I control people, and everything is optimization. I mentioned optimization. Those are the things you should be working on. Now, of course, in order to control a system, you need measurement, decision-making, actuation. Is there something I've forgotten? There's those things that need to take into account. But it's the notion of, can we model the system? Can we understand the underlying dynamics? And then the difficult part is the human factors and the human intervention. And then can we control the system and optimize it? And that's it. I mean, there's nothing more to life, is there?
Really?
I think that's it. So yeah, you're working in the right area. Just keep thinking about things like safety, like the future, like this. And again, can't stress it enough, the human factors and human behavior at a multiplicity of scales. That's the other thing. It's not simply your own small part of the picture. You have to understand the full picture too.
Given this audience, I feel very optimistic about how we can handle these problems in the future.
Indeed.
Okay, let's thank our speaker again.